Hello everyone, very good evening to all the chemical engineers aspirants out there. This is another session of the mock interview in the series of mock interview that we have taken for you guys. And my suggestion to all the engineers out there, those who are preparing for the BARC, NPCIL and the other recruitment examinations, guys must watch these interviews. These interviews will help you a lot. Okay. So with me in the panel, we have Ankush Gupta sir. Welcome, sir.
Yes, sir. Thank you, sir.
And we have one more candidate with us today. So let us know about the candidate. So you can introduce yourself.
Good evening. Myself, 𝐂𝐤𝐴𝐻 Koviraj. My hometown is Bolpur Santiniketan in Birbhum district of West Bengal. I have done my schooling from St. Teresa School and Hemsila Model School. Currently, I am enrolled in BE Chemical Engineering at Jadavpur University. My father's name is Binoy Koviraj and my mother's name is Santana Koviraj. I have done my summer training from MCPI Holdia, and during my summer training I have done distillation column designing in conversion of distillation column from tray column to packed column, and I have really enjoyed my experience there.
Okay, great. That's great. So Soumyadeep, tell me about the difference between the PI, PID and the P actions.
So P actions works on present error. When we change the controller, the step change we give step change or pulse change, and the system controller takes some time to reach the maximum value of response. And many times we see that it cannot reach the maximum value of response. There is a certain offset. So to reduce that offset, we use the types of control, the action, the controller action, that is P, PID, and PI. And proportional actions works on the basis of the error that is measured by the measuring devices. So it is a present, according to the present error, it takes decision and advise the controller to work to nullify the error in the control system. And in case of PID, the I action is the integral action. It works on past error that is stored in the system, because when the error, we know that the offset reduces to such an extent that the error is not sufficient for the controller to take decision. Then I action stores the error values from the past and then maximize the output of the controller. And for D action, the derivative action, it works on the future, that is from the beforehand it suspects that the error will be in the positive direction or negative direction, so it keeps the decision in ready for the next turn of the error cycle. So it is a future action.
Okay. So which one is the fastest? P, PI or PID?
So PID is the fastest because D action doesn't take any time for showing it action, for showing it results.
On what ground you are saying that PID is fastest? What is the meaning when I say fastest? Basis of fastest.
So it means when the error signal is measured by the measuring devices, then the controller takes some time to take the decision whether to act in this direction or not. And the D action works. The D action does the work beforehand before the error action reaches the controller.
No, my question is, when I asked you this question, out of all, which one is fastest? You literally said PID, and
Yes,
the
sir.
credit you are giving to the D action mainly. But
Yes,
my
sir.
question is now that fastest, is a word fastest, on what grounds we are judging that the PID is fastest? What do we mean by fastest? फास्ट की डेफिनेशन क्या होगी यहाँ पे?
So it
मतलब
is the
इस क्राइटेरिया के बेसिस पे हम बोलेंगे कि ये फास्ट है.
Sorry, the response time is the main criteria.
Response time is the main criteria. So what happens at the response time? What is response time?
The response time is the time taken by the controller to minimize the offset to such a level that it is plus minus 5% of the maximum value of response.
Okay, very good, very good. Okay, so tell me the different types of the second order system.
So second order system, that is one is that is inbuilt, and that is the inherent type, and one is the made up second order. Inherent type is the tank in series order, and the made of second order, in which we combine two first order system to make a second order system.
Okay, okay. So in the made up second order system, you mentioned about the Tenkin series. Is there any name Tenkin series used in the process dynamics, or something else, some else name is used?
So tank system is used. One is that is pure, that is in which the
In which there are two types of arrangement in this.
yes, sir. In one arrangement, the tank flow rate, in the second flow rate depends on the height depends on the cylinder.
What is the name of that?
Sir, name I could not recall right now.
It's non-interacting capacity and
Uninteracting.
interacting capacities. Okay. So, but there is one more type for the made up second order.
So purely capacitive, that is.
Purely capacitive is not second order. That
This
is first order system.
the mercury thermometer that.
That is first order system. My question is types of second order. You said inherently second order and the made up second order. Now the made up second order is again of two types. One is the capacity system, multi-capacity system, and one is something else. In multi-capacity, it is again two types, non-interacting, interacting. But what is that second type of made up?
So we can say valves, yeah.
Valves? No.
In actuator, it is converting from one
That
order
is
to
inherently second order. Valves, pneumatic valve comes under the category of inherently second order. We are talking about the made up second order. What is the order of PID?
so PID first order.
First order. And what is the order of the tank system? Single tank.
The single tank is also first order.
First order. So when the level in the tank system is controlled with the help of the PID, what will be the overall order?
So it will increase by one. So it will be second order.
That is the second type of the made up, na? Controller in series with the process.
Yes, sir.
Controller in series with the process. So one is the process in series with process. Another is controller in series with process. Okay. What is the nature of them? What is the nature of response? Over damped, under damped, critically damped?
So it depends on the damping coefficient. If the damping coefficient is
The
less than,
multi-capacity system I'm asking. Whether it is interacting, non-interacting, for both I'm asking. What is the nature?
so it is yeah, so it is under damped.
Under damped. And process in series with controller?
So no, so tank in series is over damped, and process in series with controller, that is PID controller, it is under damped.
Why you changed your answer?
So because in processing series with controller, we are using I action, and I action we know generates a sinusoidal wave, and for the sinusoidal wave zeta is less than 1, so it will create an underdamped system. And for the tank order system, it does not means create a sinusoidal response on its own if we do not give the input change as sinusoidal.
Okay. What are the assumptions of the Routh stability criteria?
So Routh stability criteria, it assumes that the so it states that all the signs should be all the signs in the transfer function should be same for that for the system to be stable, and also it states that the Routh element should be if it is equal to 0, then the system is marginally stable, and if the in the other elements except the Routh element is 0, then the system is stable.
What are the disadvantages of the Routh stability criteria?
So it is not applicable for frequency response analysis.
Or
So it is not applicable when the dead times comes into the system.
good. Or
So Routh array cannot determine the exact value of the KC controller proportionality constant. It can only give the range of the KC values. So the actual operating values we cannot get.
good. Or Routh array is based on the characteristic equation.
Yes, sir.
And if the order of the characteristic equation is, let's say, 6, 7, 8, 9, 10, then will it be simple to solve this or becomes complex?
It will be complex. The array system will increase the number of elements.
So what will be the next disadvantage based on this?
So it can give faulty errors. Means it can predict that the system is stable, but in reality the system can be unstable due to any one.
Routh array becomes very complex. The calculation becomes very difficult as the order of the system increases, as the order of the characteristic equation increases. Okay. And you told me that in one of the disadvantage that in the case of dead time system, the Routh array is not applicable.
Yes, sir.
Define dead time.
So dead time is the time required when the gap that is that we face when the controller action is given and the desired result is shown in the actual process. Means if we switch on the fan, switch on the switch, the fan switch, the time we switch on the fan starts, that is there is a time gap, that is called the dead time or delay time.
Any other example apart from fan?
So in process control also there is, in the valves also the signal time there is a means lag, the signal time there is a lag
You know
between
the
the.
tracer experiment we do in CRE?
Yes, sir. And
Is there any dead time?
non-ideal reactor that is dead time, because when the in CSTR non-ideal CSTR when the sum of the means reactor constituents spends a more amount of time than the space time, then it is called the dead time system.
No, that is not dead time. That is, I'm talking about the tracer experiment. Have you heard about the tracer experiment?
Yes, a tracer experiment is used to measure
What is
the
tracer experiment?
in PFR. It is.
What is this?
So in tracer experiment, we give a pulse input in the inlet of the PFR, and we measure the concentration at the exit. So we can actually predict the residence time distribution of the.
The time at which you put the tracer at the inlet, at the same time, do you get the tracer at the outlet?
No, sir.
You get the tracer at the outlet after some time.
Yes, sir.
What is that time?
So it is the space time of the that is the reactor that is in that is we are doing the experiment. That is in
Space
PFR.
time.
Yes, sir. Tau p, after tau p time we get the.
So after tau p time, you get the tracer at the outlet. Then what is that? That is no dead time.
So
Sir,
that
are
is
you talking about PFR? Any specific type of reactor?
so in
He
PFR
is
only.
talking about PFR.
He is
He is
answering the questions for PFR.
He is answering dead time explanation. I'm asking that relate the dead time explanation with the tracer experiment.
Yeah, okay.
So that
Okay. What is the transfer function of dead time?
so minus TD into S.
Minus TD into S
Or minus the transfer function hold
transfer function. Minus TDS.
e power minus TDS.
E power minus TDS. Yeah. Initially you said minus TDS.
So in that function.
Why e to the power minus TDS? How
So
it came?
because it is a exponential, the dead time sense, it decreases with time. So it is an exponential function.
नहीं, why exponential? वही तो पूछ रहा हूँ.
So it's
You know the first value theorem, first shifting theorem.
yes, sir. In first shifting theorem, we can shift a variable from from 0 time to at a time t equal to a.
First shifting property. First shifting property.
So that
You heard about this name, first shifting property?
so e power minus at we can consider at s minus a.
And second shifting property? In the first shifting, you shift the base from s to s plus a,
Yes, sir.
or s to s minus a.
Yes, sir.
In the second shifting property, you shift the base of t from t to t plus a or t to t minus a. Okay. So when we shift the base on the time domain, what we observe in the s domain?
So when we shift the base in the time domain, there is also a shift in the s domain, but the sign changes. Means if that in the time domain, if it's t.
In the first shifting, when the base of the s is shifted, what happened on the time domain?
So it comes in the exponential term, that is e power, if the exponential term was e power minus t, it becomes e power t minus t plus a.
You don't know about both of them. गलत तो मत बताओ यार, नहीं पता तो मना कर दो. The Laplace of the dead time comes from the second shifting property. When we shift the base of t to t plus a or t minus a, we see an exponential function getting multiplied with the s domain function. So what is dead time in the time domain shown? It is shown as t plus td.
Yes, sir.
That td is the dead time. So with respect to that td, you multiply the s domain function with e to the power minus tds.
Yes, sir.
That's why the e to the power minus tds is the Laplace of the dead time function, because with respect to dead time in the s domain, we see an exponential function.
Yes,
It
sir.
comes from the second shifting property. Okay. There are many disadvantages of the Routh array that you told.
Yes.
What do we do to overcome all of them, or what method of stability should we use so that we can overcome those disadvantages?
So we can use the other tuning methods to overcome that. That is 𝐂𝐤𝐿 tuning method or 𝐁𝐸 tuning method.
Tuning is different thing. I'm asking about the stability criteria. Routh stability criteria has many disadvantages. So what other stability methods or criteria we should use in order to overcome the disadvantages of Routh?
So there is one more stability that theorem that is Bode stability criterion. By using that Bode stability criterion, we can get the stability, the operating values, 𝐂𝐤𝐴
So
operating.
Bode covers all the disadvantages of Routh.
So it covers the date time system. For the date time, it can give the actual means value of the 𝐂𝐤𝐴.
Or other disadvantages of Routh.
So other disadvantages was that Routh array gives the operating range of the 𝐂𝐤𝐴, but Bode gives the actual value, the operating value of the 𝐂𝐤𝐴.
With
So
the help of?
with the help of.
Bode gives the actual value of 𝐂𝐤𝐴 with the help of what?
So in Bode we draw the curve between ln of magnitude ratio divided by the ln of
You draw the curve, you calculate the phase lag, put it equals to -180, calculate the crossover frequency, then calculate the gain of that, and you get to know whether the system is stable or not.
Yes,
And
sir.
if the system is stable, you can determine the 𝐂𝐤𝐴 value.
Yes, sir.
That is also the range. That is also the ultimate value. I'm asking how you calculate the actual value, operating value.
So for that, we can use tuning methods.
No. There is a concept for calculating the value of the optimum gain. There is a concept in Bode. What is the name of that concept?
Sorry, sir, I cannot recall.
Concept of margins. Margins.
Oh,
There are two margins.
gain margin and phase margin.
With the help of those two, we determine the optimum value of Kc. What is gain margin?
So gain margin, it is obtained by the inverse ratio of the amplitude ratio.
नहीं, define करने के लिए बोला मैं.
So gain margin is obtained when we equate the amplitude ratio of all the amplitude ratio, and we equate it to 1. Then we obtain the
Definition पूछी है मैंने, formula नहीं पूछा. I'm asking the definition. What is gain margin? You are telling me how to calculate gain margin. I'm asking how to define gain margin.
So gain margin is the parameter which is obtained to define the stability criterion of a system. And Bode defines that gives the
Stability
thumb.
criteria is defined by Bode, not by gain margin.
Yes, sir. Bode defined the gives the thumb rule of the gain margin, that it should belong from 1.7 to between 1.7 and 2 for the system to be.
मना कर दो ना, नहीं पता तो definition. Gain margin is the safety margin that tells us about the degree of stability. More the gain margin, more stable the system will be. Okay? If the gain margin is unity, system will be at the verge of instability. So gain margin and phase margin both are the safety margins that tells us about the degree of stability, how stable our system is. So Routh array can tell whether the system is stable or not, but it cannot tell the degree of stability, means how stable. If I say that the system is stable, okay, how much? No answer given by Routh. But in the Bode, with the help of the gain margin and the phase margin, now we can also tell how much. We have the number now. So if I have two systems having a gain margin of 2 and 3, then the system with a gain margin of 3 will be more stable. We know the degree of stability now. We can compare two stable systems with each other and can tell which one is more stable. Okay, that is the advantage of the Bode. Okay, great. Ankush sir.
Yes, sir. So Soumyadeep, what other subjects you have prepared for the interview?
So mass transfer operation, heat transfer operation, fluid mechanics, and instrumentation and process control.
Other subjects I was saying.
So mass transfer operation, heat transfer, and fluid mechanics.
Okay. So let's start with mass transfer, some very basic question, and then we will talk about the fluid mechanics. Do you know what is the process happening in NPCIL?
So in NPCIL, we use the nuclear energy to convert it to electrical energy.
So can you tell us how? The steps?
So in pressurized heavy water reactor, I can give the example.
I don't know. If I just tell me whatever you know.
Okay, sir. In pressurized heavy water reactor, we use the uranium as a fuel, and we have control rods to control the temperature of the uranium. And as a coolant, we use deuterium oxide during that fusion reaction, the heat is produced, and that heat is used in the generation of the steam, and this steam is sent to the turbine, and from turbine we can get the work done. And from that work done, we can convert it into electrical energy.
Okay, so what is the conversion chain there?
So conversion chain means in the reactor.
In the plant.
So in the plant,
Nuclear power plant.
Nuclear power plant is the steam is used in the rotation of the turbine, and the turbine is producing the work done.
Whatever you said earlier, that is the conversion chain. Conversion chain means
Nuclear energy to
transformation of energy from one state to another.
Yes, sir.
The nuclear energy is basically the chemical energy to
Electrical energy.
electrical energy. Now I have one question. That is the nuclear energy which is getting generated as heat, or it is the chemical energy?
So nuclear.
What is the difference between these two?
So nuclear fuel we are burning to get the chemical energy.
Yeah, in thermal power plant we burn the coal.
Yes, sir.
To do the same. That is the only difference. Here we have coal, here we have nuclear reactors. So that is my question, that energy, the first thing in conversion chain, it is the nuclear energy or the chemical energy, or both are same?
No, sir. Nuclear energy, it is that is used as a fuel gas. So we can use the chemical first term as the chemical
I'm
energy.
not asking how we use. Like if I ask you the difference in potential energy and kinetic energy, can you tell that?
So potential energy is the energy that is processed by a body due to the position in respect to the ground, and kinetic energy due to due to the velocity present in the system, the body that is considered.
Sorry, kinetic energy is?
So the velocity of the body that is in consider, the velocity of the body of the
Okay, due to velocity, motion. For potential energy, you said position. It is position or height? Because
height,
position could be along the ground as well.
position with respect to ground if it is at a height or.
So with respect to ground, suppose this is my ground. Body is here. Now body is here. Now body is here. At three different positions with respect to ground. The potential energy will be different as per your definition.
No, sir. Its position means with respect to the vertical direction.
Then say na elevation or vertical or altitude or something like this. Okay, so this is the difference: potential energy due to elevation, kinetic energy due to motion. Similarly, what is the difference between nuclear energy and chemical energy?
So nuclear energy, it is the energy obtained due to fission reaction, in which the uranium particles
Only
collide.
uranium particles can possess that.
So uranium and plutonium also.
Only uranium and plutonium.
Other fuels are also there, uranium, plutonium.
Then why you are just generalizing this by using the term uranium? Say nuclear fuels.
Yes, sir. So
or radioactive elements, whatever you like to say.
So during fission reaction, that particles split and then release the energy that is stored in between the
particle splits or what?
So uranium, uranium 235.
In uranium, why you are in love with uranium? Why?
Sir, because in pressurized heavy water reactor, the uranium fuel is used. So,
what is fast breeder reactor?
So in fast breeder reactor, we use the plutonium that is generated by the pressurized heavy water reactor as a waste.
Pressurized heavy water reactor, and then you will say uranium. Move ahead from uranium. I asked you the very simple question. What is the difference in nuclear energy and potential and chemical energy? And you are going to all these things. Now later on you will talk about the stage 3 reactors also. I'm not going in that direction. Why you want me to take you in that direction also? Just keep it simple. And it's not substance. Nuclear fission, don't use the term substance. The component does not split. What is split in the radioactive nuclear fission reaction?
No, sir. Yeah, it's atomic number that two particles are formed. Which
what is atomic structure?
So atomic structure is a composition of the valence bond and the electrons distribution, and also the number of neutrons and protons in the atom.
Where they are present.
in the nucleus of the cell.
Yes. Nucleus. That's why nuclear. So nuclear fission, what splits?
Nucleus.
And in nuclear fusion reaction, what combines? Components or their nucleus?
Nucleus.
Got it? Because
Yes,
if
sir.
you are saying component will split, that means you are saying along with the component, its proton, neutron, electron, all will split.
Oh.
While in radioactive reactions, in a nuclear fission reaction, only nucleus is getting split. That's why there is a proton and neutrons. But do we talk about electrons there?
Okay.
Because nucleus is getting split. We don't care about the electrons. They get released in the form, if electrons are getting released, that is what we call beta rays.
Yes, sir.
So what is alpha rays?
So alpha rays when the proton that changes to
Correct.
that.
So now have you understood the difference between nuclear energy and chemical energy?
Yes, sir.
So tell me.
So nuclear energy when the nucleus of the means atom and that splits into two
Not
fragments.
splits. Nuclear fusion also happens, Baba.
Yes, sir. Either splits or
Participate in
combines.
nuclear reaction.
Either splits or combines to make to form another compound. So it releases energy in form of nuclear energy, and that energy is in later part is utilized by the chemical as a chemical energy.
What is chemical energy? But
So chemical energy is the energy processed by the means chemicals in the form of heat energy or in the form.
do you have you seen an LPG cylinder?
Yes, sir.
So there is something present inside the cylinder.
Yes, sir. Compressed
When you
natural.
connect that with the burner and ignite that, it undergoes the combustion process.
Yes, sir.
Correct?
Yes, sir.
So what is the combustion means release of heat.
Yes, sir. Along with
So
CO2
which
and
energy is present in the fuel which is converted into heat?
sir, in the fuel that is the chemical energy.
Chemical energy. So that is what I'm asking. What is chemical energy? How will you define what is chemical energy?
The chemical energy is defined in that way that
In this battery, which energy is present?
sir, chemical energy.
Chemical energy, which converts directly to electrical energy and heat.
Yes, sir.
Correct?
Yes, sir.
So now define what is chemical energy.
So chemical energy is the energy stored in form of the chemical and when we use it to convert into other sources, it then generates the other form of energy.
Which type of chemicals are present there?
So in nuclear power reactors or
Now you said chemical energy is stored in the form of chemicals. So which chemicals I'm asking?
so it can be numerous. That is in water we can see that the distilled water is used as a chemical for storage of energy, and in batteries we can also see that the galvanic cells stores the energy.
Kelvin scale?
It's a galvanic cell.
What is that?
So it is made of that lead and other proper materials which store the energy.
Again, let me simplify. When we talk about the atomic structure, one is nucleus,
Yes, sir.
and second thing is in atomic structure, one thing is nucleus. What is the second thing?
So in electrons, that is the balance.
Due to the changes in electrons, bond formation occur, ionic bonds.
Yes, sir.
Covalent bonds are also there due to the electrons exchange, sharing.
Yes, sir.
If you want to break those bonds between the atoms,
Yes, sir.
or if any bonds break by itself, it will release some energy.
Yes, sir.
And if you want to form the bond, you need to supply the energy.
Yes,
What
sir.
is that energy? Called chemical energy. Got it? So in
Yes.
atom, the energy due to the split or combination of nucleus is nuclear energy. And on the other side, the energy due to the electrons or electron configuration, you can say, or bonding, whatever you like to say, that is chemical energy.
Yes, sir.
Got it?
Yes, sir.
This is one line you have to answer. And because of this one thing, we have discussed so many other stuffs. समझ रहे हो? This is what we have to do. If we know the things, answer. If we don't know, simply say no. Don't try to cook up any story. And selection of words is very important. Like you said, uranium, uranium, uranium. You know how many types of uraniums are there? If we talk about the isotopes, how many isotopes are there for uranium?
Sir, exact number I don't know.
But there are many of them. Like
yes, sir.
only carbon has 4 isotopes.
Yes, sir.
So uranium can have so many.
Yes, sir.
So you will get trapped in this thing if you use the term uranium. So don't try to use any fancy word. If you can use simple or generic word, try to use them. Don't specify. Otherwise, it will be trouble for you. Okay. Now let's try it. What is the nuclear reaction taking place on the sun?
So it is fusion.
Sorry?
Fusion.
Nuclear fusion.
Yes, sir.
Any other example you can tell me where the nuclear fusion reaction takes place?
So in hydrogen bomb, it is used nuclear fusion.
Hydrogen bomb.
Yes, sir.
What is hydrogen bomb?
So two H2 molecules combined to give a fusion and release the heat energy.
Okay. So between suppose I have one hydrogen bomb, one atom bomb, nuclear bomb. In both those, the respective fuels, whatever are they use, are in the same quantity. So which one of them will be more deadly?
So in fusion reaction, we need a initial energy, that is high amount of energy for the two atoms to combine, means nucleus to combine. And in fission reaction, we do not need that much energy. So the initial energy, if we supply, then the fusion reaction will generate a much more energy than the fission reaction.
That's correct. But which one of them will be more deadly?
So fusion reaction
Which bomb?
or hydrogen bomb.
Hydrogen bomb. So if I want to throw hydrogen bomb on any city or town or at any place, let's say,
Yes, sir.
then first I need to supply the energy, as you said.
Yes,
So
sir.
how will I go? What is the benefit of making the hydrogen bomb? And if I cannot use it,
Sir, it is useful because there is no waste generation in the fusion reaction, because H2 molecules combine to give water, and in fission reaction there is a waste generation, that is. And if we give that much energy, the energy produced after fusion reaction is much greater. So it is not used as means hydrogen bomb is not used as a warfare technology, but to get more energy in return. So we can convert it later to electrical energy in much greater scale.
So based on this logic, what is the main characteristic of using breeder reactors? Main benefit of using breeder reactors.
So to decrease the means to recycle the products that is generated and to so that there is a minimum contamination in the cycle. It is used as a cycle in three.
It is same as the thing which you just mentioned about the hydrogen bomb few seconds earlier.
And that is it generates H2O, and so that the
In breeder reactors, we introduce the fuel,
yes sir.
and in returns, it produces the fuel.
Yes sir.
So here the fuel consumption is less and fuel generation is more. But the difference is the fuel consumption is the fuel which we are sending is different. But the fuel which is getting generated, that is different, which will be useful for the stage 3 reactors.
Yes sir.
Three-stage nuclear plant.
Yes sir.
Okay. Anyways, I don't wanted to do this discussion. My target was mass transfer. But it is good to know that you have such a good, great idea about these things. So my question, which I was supposed to ask, was in these nuclear reactors, if we have to talk about the concepts of mass transfer, which you have studied for your GATE exam.
Yes sir.
So what are the concepts you can visualize or see in nuclear reactors?
So one, we can see that in boiling water reactor, we see that the water is directly
Why you are
boiled.
using the name of the equipments? Initially, you were talking about the pressurized heavy water reactor. Now you are talking about the boiling water reactor. I know you have done the study. Try to avoid those things. Just answer the simple question. If I ask you, how many people live in your house? You will simply say the number, or you will start to giving the biodata of each and every person.
No sir, only number.
In the same way, I am asking, what concepts of mass transfer you can see in the nuclear reactor?
So
Just name them.
we can see distillation because we are using water as a coolant. So if it gets contaminated by any other radioactive fuel, we need to separate means we need to obtain the purified water before we can reuse it for the next purpose as a coolant.
Only distillation, which is not present in nuclear power plants till even in their wildest dreams. Have you seen distillation column in any nuclear power plant?
Sir, I am not sure about it. That
What was my question?
so in
I
mass
wanted
transfer.
you to see the mass transfer concepts where?
Yes sir.
Where did I ask you? In nuclear power plant or nuclear reactor?
The nuclear power plant.
I ask you for nuclear reactor. In the nuclear reactor.
So in the nuclear reactor mass transfer operation.
What concepts of mass transfer we can see? Simple. That is the question. Why you are taking these things to your imagination and nuclear power plant? Just talk about the nuclear reactor. It could be any type of nuclear reactor. I am not going in that. If a reaction will occur, will there be any transportation of molecules?
So in nuclear reactions, there will be transportation of the coolant supply.
Why you are stick to the coolant? In nuclear reactor, why we will use nuclear coolant? What we will do with coolant in nuclear reactor? If you send the coolant in nuclear reactor, how will you be able to utilize that energy which is getting released? In nuclear reactor, that energy, you said earlier, nuclear reaction occurs, heat energy release, which is utilized to produce the steam.
Yes, sir.
Correct? So if you are sending coolant to the nuclear reactor, so they will absorb that energy. So how you will going to generate the steam? Because
Sir,
coolant cannot be used to generate the steam. Correct?
no, sir.
In mass transfer, what is the first chapter you study?
So in mass transfer, there are two types of that is mass transfer, that is bulk motion and molecular diffusion.
I asked you the name of the chapter.
Mass transfer operation name means the types of mass transfer, that is distillation X.
That is topic. Chapter. You have studied heat transfer.
Yes, sir.
What is the first chapter?
So, and that is heat transfer of that the temperature difference, that is the driving force.
That is chapter. Do you understand the meaning of chapter and topic? I think you are getting little nervous. Have some water.
No, sir, it's okay.
Thank you. Have some water. Hello, Soumya. Now fine? Feeling better? See, one thing I will tell you as a feedback, that you have quite a good knowledge, but the problem is you are just mixing all the concepts. Your approach is like, let me tell everything, each and everything, whatever they are, I know. ठीक है, यही है ना? आपको ऐसा फील हो रहा है कि are you comfortable with Hindi?
Yes, sir.
हाँ, so you are feeling like कि if they are asking anything, I know this much thing, so let me explain all these things. ठीक है? This is not a good approach in interviews, because that is interview. One too many. And if you will speak so much, what they will do? Whatever they are asking, listen carefully, take 3-4 second pause, and then answer. Only the relevant information. Don't try to generalize anything, don't try to cook up any story, and don't try to speak everything. They know you have the idea of all this, but they are not interested in all this. They are interested only in this much thing, which is related to the question. And that is the work of a scientist. To use the exact information, pinpoint information, only then they can do the research and discoveries.
Yes, sir.
And developments. Correct? तो इस चीज का ध्यान रखना. सब कुछ नहीं बताना है, जितना पूछा गया है बस उतना बताना.
Okay.
And third thing is, during the interview there also, if you feel nervous, just ask them for a minute, take a breath, close your eyes, try to just calm down yourself, and then answer. Because आप जब पैनिक हुए तो आप पता नहीं क्या क्या करना शुरू कर दिया. आप चैप्टर नहीं बता पा रहे थे यार. हीट ट्रांसफर, कंडक्शन, कन्वेक्शन, रेडिएशन, यही होते हैं. मास ट्रांसफर में डिफ्यूजन, मास ट्रांसफर कोएफिशिएंट, इंटरफेस, मास ट्रांसफर, डिस्टिलेशन, ये चैप्टर का नाम है. आप पता नहीं क्या क्या बोल रहे हो, और ये सब चीजें आपको पता है ना. तो वही मैंने कहा, पैनिक नहीं होना. ठीक है? अगर हो रहा है ऐसा कुछ फील, नर्वस हो रहे हो, तो 1 मिनट का पॉज ले लो, पानी पियो, वहां होगा आपके पास, वो ऑफर कर. आंखें बंद करो, खुद को शांत रखो, फिर आंसर करना स्टार्ट करना, ठीक है? अदरवाइज कोई फायदा नहीं। नर्वस होके आपको पता कोई सिलेक्शन होगा क्या? नहीं होगा। बाकी कॉन्फिडेंस के साथ जाओ, आपकी नॉलेज अच्छी है, बस लिमिटेड नॉलेज देना, ठीक है? दैट इज माय फीडबैक। बाकी सर आपको बताएंगे।
Soumyadeep, first of all, ki you are looking prepared. You are prepared. That is a plus point for me. Second thing, you also look confident. That is again a plus point for me. And again, the third thing is you are not taking gaps in answering. Like many of the students, when they explain, when they answer, they take so much time in defining even the one thing. Okay, oh, ha, hi, ha. So they take time, but there is no gap. There is clarity in your mind. That is again a plus point. And the fourth thing, you have a good clarity about the IPC, because this time in the NPCIL, straight away they're asking the IPC questions, and for many students, only IPC they're asking. And by asking the questions regarding the IPC, it looks like you have a good knowledge about the IPC. I don't know why you fumbled when Ankush Gupta sir asked you some questions, because in my time when I asked you some questions, you gave the perfect replies. And even when you are unable to reply, at least you are picking up the hints. So that's good from my side. Hari Jhandi, green signal from my side. But don't get fumble in the real interview. Okay. It may happen that one of them may try to put pressure, but don't feel pressure. Okay. Like Ankush Gupta sir said, take a breath, have some drink of water, and then just reply in the same way that you are giving. Okay. So the way you are giving the answers of my part should be the way for the whole interview.
Yes, sir.
And then you will be surely selected. There is no doubt, because you have the knowledge, you know the answers, and you are prepared, you are confident. So best of luck from my side.
Thank you, sir.
All the best from there.
All the best.
Thank you.